Hello Godotneers! In part 2 of this video series about G.U.I.D.E, we're going to add controller support to the game that we made in the first part. And we're going to do this in a way that doesn't need any changes to our input handling code. We'll look at how we can seamlessly switch between keyboard and mouse and the controller while the game is running. And we are going to explore how we can show input prompts to the player so the player knows what to do. Finally, we'll look at how we keep these prompts up to date when the player changes between keyboard and controller and our two game modes. Like the first video, this is an intermediate level tutorial. To make the most out of it, you should already know your way around Godot, so you should know the basic features of Godot like nodes, scenes, signals, autoloads, and of course the G.U.I.D.E script programming language. It will also help a lot if you are familiar with the basics of G.U.I.D.E, so if you haven't watched part 1 of this video, now would be a good time. If you'd like to follow along with the video, you can download the example project we're using from GitHub. There's a link down in the description. Since the last video, G.U.I.D.E has received quite a few improvements, so in this video we're going to use the latest version that is currently available. If you use the example project from GitHub, your G.U.I.D.E version is already updated. But if you follow along with your own project, make sure you have updated G.U.I.D.E to the latest version. You can find a link to the update instructions in the description. We start with our game just as it was at the end of the first video. Now let's say we would like to use a controller rather than the mouse and keyboard to control the game. How would we do that? Well, let's connect a controller and find out. I have an old Xbox 360 controller here, but G.U.I.D.E works with any controller that is supported by Godot. Now, we could just use our existing mapping contexts and add more input bindings for each actions. So we could take our walk mode context here, and maybe here for the shoot action, we add a second mapping, and let's bind this to the right trigger, and let's add a pressed trigger. And now if we run the game, we can use both the right trigger and the left mouse button to shoot our magic bolts. Now that works, but it has a few problems down the line. First, it makes it harder for us to show input prompts to the player, because shooting is now bound to both the mouse button and the right trigger. We would need to tell the player something like, press left mouse button or trigger on your controller to shoot, which is a bit clunky. It would be better if the input prompts only show the buttons for whatever input device the player is using right now. Another problem with this approach is that inputs might start to fight with each other. For example, in build mode, we use the mouse to place towers. If we now want to place towers with a controller stick, this would clash with the mouse input. Both devices send data, and our game would now need to decide if it reacts to input from the mouse or from the controller. So in most cases, it is a better idea to have a separate mapping context for each input scheme. We already have mapping contexts for keyboard and mouse, so let's now create some for the controller. So we select the walk mode mapping context here and duplicate it. And let's name it walk mode controller. And to be consistent, let's rename the other mapping context to walk mode keyboard and mouse. Now we can open up our controller mapping context. We want to have the same actions, just triggered by different inputs. Let's start with moving the player, and let's first clear out the input mappings with this clear button. And then we add a new input mapping and press the pen icon. And we want to move with the left stick of the controller. This is a 2D input, so let's click the 2D button and then move the left stick. And G.U.I.D.E has detected it nicely. We'll accept this, and now we need to think about how our game expects the input to look like. In the first video, we built the input so that left and right movement is on the x-axis and forward and backward is on the z-axis, because that will work nicely with Godot's default 3D transforms. So how does our input look when we get it from the controller? Well, let's have a look at G.U.I.D.E's documentation. It has a list of all supported inputs. G.U.I.D.E uses a joy axis 2D for the controller's left stick, and we can see that for this input, we get the input in the X and Y components of our input vector. So we need to swap the Y component with the Z component, and we know that we can use an input swizzle modifier for that. So let's add one of these, and then we set the order to X, Z, Y. So we swapped the Y and Z components of the input vector. Okay, so now we just need to make sure that the game uses our new controller mapping context. So let's go to our main scene, select the root node, and then we can drag our walk mode controller mapping context into the walk mode export that we have created in port 1. So when the game starts, it should now use our controller input. Let's give this a try. And now I can move the player with the left joystick button, and we didn't need to change any code at all. Really nice. There's a small problem though. My player seems to be drifting a bit. And if we have a look at the debugger, we can see that the input isn't 0, even though I released the left stick. So the player moves even if the stick isn't actuated. Now, my Xbox controller is pretty old, and over time, many controllers will show some stick drifting, so this is a pretty common problem. We can fix this with a dead zone modifier. This modifier will ignore all input that is below a certain threshold, and this should fix our drift problem. So let's add a dead zone modifier to our input, and let's try again. So now, when I move the player and release the stick, we can see that the input still drifts, but our move action up here gets a nice 0, 0, 0, and the player doesn't move anymore. Nice! So now we have the controller movement. Next, we want to rotate the player and the camera with the right stick on the controller. So let's go back to our mapping context and let's have a look at the player rotation first. We click on the pen icon so we can change the input, and we want to move the right stick left and right to rotate the player. So we click 1D axis, and then we'll pull the right stick to the right, and G.U.I.D.E successfully detects right stick horizontal. Well, let's accept this. And now we need to think about how we map this input into the form that our code expects. For rotation, our code expects an angle in degrees. But rotating the player with the mouse is actually quite a bit different from rotating with a joystick. For the mouse we said, if the player moves the mouse a certain distance, we rotate by 360 degrees. But with a joystick, we don't have a distance, we just got a value telling us how far the joystick is actuated. So this will need to work a bit differently. What we can do is say, when the stick is fully actuated, the player does one full turn in 1 second. From the documentation, we know that the stick value goes from -1 to 1, so we could multiply the input value with 360 to get some angle in degrees. Now let's do this. We click this clear icon here to clean out the modifiers, and then we add a new scale modifier. Now for a joy-axis 1D input, the stick value will be in the X component of our vector, so we will multiply the X component with 360 and we'll leave the other components as they are. Well, let's see how that works. And this is way too fast. It also looks like my right stick is drifting as well, so we are going to need to fix this later. But why is it rotating so fast? Well, our game applies the rotation from the input every frame. So when the stick is fully actuated, we do one full turn every frame. But we want one full turn per second, so how can we do this? Well, if we have a look at our modifier again, there's a checkbox here, Apply Delta Time. So when we check this, our value will be multiplied with delta, so our 360 degrees per frame now become 360 degrees per second. And this should fix the problem nicely. Let's also add another dead zone modifier to fix the right stick drifting, and we can move this up so it runs before our scale modifier. Now we can give this another shot, and that's a lot better. But the player rotates in the wrong direction. When I move the stick left, then the player turns right, and vice versa. Now, some people like it that way, and some people don't, so that is something we will need to make configurable so the player can set it up in a way that they like. We'll do a settings menu in a later video, so for now let's just pop in a negate modifier which will invert the value. Let's try this again. And now we can rotate the player with the right stick. Really nice. Next is rotating the camera, and this is pretty much the same as the player rotation. So let's delete the old mapping and duplicate our player rotation mapping. And now we only need to drag the rotate camera action in here and use the pen icon to change the binding. And this time it's the vertical axis of the right stick, so we click 1D and then move the stick up or down. Now let's press accept, and that's it. Let's try this out, and now we can rotate the camera up and down with the right stick. Great. The last thing is shooting, and for that we're going to use the right trigger. So let's change the input mapping for shooting. We click the pen icon, and as we have seen in the beginning, the right trigger is actually an analog input. So it's not in the Boolean section, but rather in the 1D section. So we click on 1D and press the right trigger, and now we can accept this. Let's also have a look at our pressed trigger here. This is still what we want. The player should only shoot once when the trigger is pressed. But when we look at the settings, we can see that the actuation threshold is set to 0.5. And this means that the trigger needs to be pressed at least halfway down to trigger the action. And that may feel a little clunky in game, so let's change it down to 0.2. Now it is enough if the player only presses the trigger a little bit to fire a magic bolt. And these little tweaks really help with how the input feels to the player. Okay, let's try this out. And now we can shoot with the right trigger. Really nice. So now we have the walk mode of our game working with a controller, and we didn't have to change a single line of code in our game to make it happen. Now let's see if we can do the same thing for the build mode. There's one action left in our walk mode, and this is the switch to build mode action. Let's bind this to the left bumper of the controller. And now we can go over and create a controller mapping for our build mode. Well, let's duplicate the build mode mapping context, and we name the copy build mode controller. And to be consistent, let's also rename the mouse and keyboard mapping to build mode mouse and keyboard. Now in our world root node, we drag in our new build mode controller mapping context. So now both modes will use a controller. And that takes care of the basic setup, so let's change the actual input mappings. The first mapping is switch to walk mode. So let's change the binding here to the left bumper, so we can now use the left bumper to toggle between build mode and walk mode. Now to select the tower, let's go with directional pad up. This way we can add more building types later and bind them to the other directions of our directional pad. Directional pad is a Boolean input, so we click Boolean and then the directional pad up. For placing the tower and cancelling the placement, we use the A and B buttons because in most games, A is used to perform an action and B is used to cancel an action. Next is camera movement, and we want to do this with the left stick, so let's clear out this mapping and bind it to the left stick. Let's add a dead zone modifier so the stick doesn't drift, and like for our player movement, we want to add an input swizzle to swap the positions of the Y and Z parts of our vector. Okay, let's maybe give this a try so we see that everything still works. We start in walk mode and we press the left bumper, and now we're in build mode. And if we press the directional pad up, a tower appears. It currently is locked to the center of the screen, but if we move our camera around, the tower will follow. So we can actually press A to place the tower. Let's try this again. Directional pad up to select the tower. And if we press B, the tower disappears. Great, so this could actually work just fine this way. But let's say we want to move the tower independently of the camera, like we can when we use keyboard and mouse. We still have the right stick of the controller, so we could use that to move our tower. So let's bind the right stick to our two actions here, which have the 3D and 2D tower positions. And let's also add a dead zone modifier at the top, so we don't get any drift. Now, the problem is that our 3D coordinates and canvas coordinates modifiers expect a mouse position. But when we use the stick to move the tower, we don't have such a position. We just have an input pointing into a direction. So, do we have to change our code after all to make the game work with the controller? Well, no, because there's another modifier that can help us with that, the virtual cursor modifier. The virtual cursor starts up in the middle of the screen, and whenever we feed input into this virtual cursor modifier, then the modifier moves the virtual cursor and outputs a 2D position of where our virtual cursor currently is. And then we can feed this position into our 3D coordinates and canvas coordinates modifiers, just like we would feed the mouse position in. So let's add a virtual cursor to both our actions here. And the virtual cursor goes in the middle, so after the dead zone, but before the 3D and canvas coordinates modifiers. And that should do it. So let's try this out. Left bumper to switch to build mode, directional pad up to build a tower. And now if I move the right stick, we can see that the tower moves independently of our camera. And when I move the camera, then the tower moves with the camera as well. So this is really nice. We just added full controller support to our game without having to change a single line of code. Now, this might not be possible in every situation. Sometimes the input schemes are just too different. For example, if we were to add mobile support to this game, we would still need to add some custom code to show some virtual joysticks and maybe even some extra buttons which we don't need when we play on a computer. But for now, this is working nicely, so let's move on. Now it would be really nice if we could switch between the controller and keyboard and mouse input schemes while the game is running. And to make this really easy for the player, the game should do this automatically, so when the player plays with keyboard and mouse and decides to pick up a controller, then the game should detect this and automatically change the input scheme to controller. And this should, of course, also work the same way the other way around. So how can we do this with G.U.I.D.E? Well, first we're going to need some actions that can trigger the change. So let's duplicate our shoot action here and name this switch to controller. And then we make another copy which we will name switch to keyboard and mouse. Now these actions are active no matter whether we are currently in build mode or walk mode. So I think it is a good idea if we add a set of global mapping contexts which have all the actions that should work globally. So let's drag these two actions one level up so they are no longer in the walk mode folder. And then let's create two mapping contexts, one named global controller. And we duplicate that and make a second one, global keyboard and mouse. Great, so now we can set up the input mappings for this. Let's start with keyboard and mouse. So let's open up the global keyboard and mouse context. Now, when we are using keyboard and mouse, we want to switch to controller input whenever a stick on the controller is moved or a button on the controller is pressed. So let's add an action mapping and we drag in our switch to controller action. And then we add an input mapping. Now we can use a special guide input to detect if any controller movement was done. We click the pen icon, and then here on the right-hand side, there's an input named any input. And if we hover over it, it reads input that triggers if any input from the given device class is given. Now that sounds exactly like what we need, so let's click on that one. In the inspector, we can now select which kind of input we want to react to. So let's pick joy buttons and joy axes. Let's also add a pressed trigger, so this will only activate once when we get the input. That was it for the keyboard and mouse input scheme, so let's do the same for the controller input scheme. We open the global controller mapping context, we add an action, we drag in the switch to keyboard and mouse action, and then we add another binding with the any input, but this time we select mouse buttons, mouse movement, and keyboard. So whenever the player presses a key, clicks a mouse button, or moves the mouse, we switch back to keyboard and mouse. Okay, now we have all our mapping contexts set up, but we still need to add the code to do the actual switching. And this now has become a bit more complex. Now let's draw up a little state diagram of our new setup. So we can be in one of 4 states. We can be in walk mode using a controller, we can be in build mode using a controller, and we can be in these 2 modes using keyboard and mouse. And there's quite a lot of ways in which we can switch between these 4 states. So how do we go about this? Well, the first thing that helps us is that switching the game mode between walk mode and build mode is actually independent from switching the input device. So our game code doesn't really care about which input device we are using. It only cares about in which game mode we are. So we can separate all of this input scheme switching from our actual game logic, and our game should still work nicely. Right now, we have the input scheme switching in our root node on the main scene. So let's delete everything from here that looks like switching input schemes. So these mapping contexts can go. In the switch to build mode function, we can remove these lines and also this one here with the mouse cursor. And we can do the same thing for the switch to walk mode function. Okay, so now the root node really only does gameplay stuff and doesn't care about our input mappings. And all this input mapping stuff now moves into a new node, which is only concerned with handling the input mappings. So let's press Ctrl A to add a new node. And this can really just be a plain node, and we call this Input Manager. Let's add a script to it, and we put this into input.manager.gd. Nice. So let's add in all the mapping contexts for keyboard and mouse. And then for the controller. And now the actions that we need. We need the switch actions between walk mode and build mode. And the switch actions between controller and keyboard and mouse. Okay, so now we can drag all of these into our inspector. And we have the basic setup done. Next, we can build ourselves a little state machine. Really nothing too complex. When we look at our diagram, we have 2 independent states. The game mode, which can be either walk mode or build mode, and the input mode, which can be keyboard and mouse or controller. So to keep track of this, let's quickly add 2 enums for the modes and 2 variables which can hold this. So we have an enum for the game mode, and this can be either build mode or walk mode. And we add a variable to store the current game mode, or game mode. This is a game mode, and we begin in walk mode. And now let's add an enum for the input mode. And this can be either keyboard and mouse or controller. And let's add a variable to store the current input mode. and we start with keyboard and mouse. Next, we can write the actual code that updates our mapping context based on what is in these two variables. So let's write a new function. We call it update input. And in this function, we look at the input mode. So let's do a match input mode. And if we use keyboard and mouse, well, then we enable the global keyboard and mouse mapping context. We do this with G.U.I.D.E, enable mapping context, global keyboard and mouse. Now, there could already be some mapping context active, so we will need to disable all other mapping contexts. And to do this, we can just add a true here as the second parameter of our enable mapping context function. Now we need to check our game mode. So we do a match on game mode. And if we are in build mode, we enable the build mode mapping context for keyboard and mouse. And if we are in walk mode, well, then we enable the walk mode mapping context for keyboard and mouse. Okay, that's 50% done. And now we need to do the controller part. So if the input mode is controller, and like for the keyboard and mouse, we first enable the global mapping context for the controller. So G.U.I.D.E enable mapping context, global controller. And again, we add the true here to make sure that any other mapping context that is currently active is disabled. And now we can check the game mode and enable the mapping context for the game mode that is currently active. So match game mode. And if the game mode is build mode, we enable the mapping context for build mode controller. And for walk mode, we enable the mapping context for walk mode controller. Now there's one thing missing, and this is the mouse cursor. We removed the code for controlling the mouse cursor from our main script, so we need to add it back here. When we look at our 4 states, the mouse cursor is only visible in build mode and only when we're using keyboard and mouse. In all other cases, it is hidden. So let's add a line up here to hide the mouse cursor by default. So input mouse mode equals input mouse mode captured. And here where we activate the context for build mode and keyboard and mouse, we add a line to show the mouse cursor. So input mouse mode is input mouse mode visible. Okay, almost done. Now we need to change our modes when our actions are triggered. So we have one set of actions that changes the game mode, and we have another set of action that changes the input mode. Let's first build 2 helper functions for switching the game mode and the input mode. So we start with set game mode, and this takes the new game mode as a parameter. And in here, we just update our game mode variable with the new game mode, and then we call update input, which will make sure that the correct mapping contexts for the new game mode are activated. And then we can make a copy of that and call it set input mode. And this takes an input mode as parameter and updates our input mode variable. And at the end, we still call update input, so the correct mapping context gets activated. And now in our ready function, we can wire up our action signals to call these functions. So when the switch to build mode action is triggered, we set the game mode to build mode. And when our switch to walk mode action is triggered, we set the game mode to walk mode. And then we can do the same thing for our switch to controller and switch to keyboard and mouse actions. And we need to have something at the beginning. So let's call update input here. So when the game starts, we start in walk mode and with keyboard and mouse input. So that was quite a bit of code, but we have a reasonably complex input system now, and this logic needs to go somewhere. The good thing is that the rest of our game code is not really concerned with this at all. We got it all nicely here in one place. So let's try it out and see if it actually works. So we start with mouse and keyboard, and I can walk around and fire. So now I switch to the controller, and the game automatically switches over to controller mode. Let's enter build mode, then D-pad up to choose a tower. Let's move it around a bit with the right stick. Well, this works. And now let's move the mouse, and the tower is now controlled by the mouse cursor, and the cursor is actually visible. Well, let's press A on the controller to place the tower, and we can see that the mouse cursor is disappearing, and we can press the left bumper to leave build mode. So this works really great, and we can at any time seamlessly switch between controller input and keyboard and mouse input. Now that we have controller support added, it would be nice if we could show to the player which input triggers which action. Many games often do this during a tutorial phase, and some games also show inputs when they become available. For example, you can walk up to some NPC or some door in the game, and then the game shows you something like press E to open this door or press E to interact with this NPC. Now let's start with something simple for walk mode. First, we need a label to show our input prompt. We don't have a place for this right now, so let's first add a new canvas layer to our game. Control A, canvas layer, and let's name it hard. I'd like to have the label somewhere up here in the middle of the screen. So let's add a center container first, and we anchor this up and in the middle of the screen. And then let's add a label, and let's name this input prompt. And we give it some text so we can see how it will look. Some prompt here. Okay, now the label is a bit small, so we just do it quick and dirty and go down here to change the font size to maybe 32 pixels. We may add a theme to our game later on, but right now we just want to get something going. Now I think this label could move a bit down, so let's drag the center container a bit down so the label has some breathing room, and that's good enough for now. I think we can also hide our debugger for now because we have the input pretty much working. So now we want this label to show which buttons make the player move. So let's add a script to our label and let's save it as prompts, prompt label 3D. And if we want to find out which input is bound to an action, we're going to need this action first. So let's add an export for our action. This is a guide action. And then we can drag in the move action into the new field in our inspector here. So now in order to show the input prompt, we need to do three things. First, find out which key is currently bound to the action. Second, format this key into some text. Third, show the formatted text in our label. Now, that looks easy enough, but it can quickly get complicated. For example, we actually have 4 keys WASD bound to our move action when playing with keyboard and mouse. But when we play with a controller, we only have the left stick. Also, the key labels depend on the locale that the player is currently using. For example, the key that is next to the left shift key is labeled Z on an English keyboard, but it is labeled Y on a German keyboard. Also, we just added controller support to our game, so the input that is bound to an action will change whenever we switch between our input methods. So it looks like showing an input prompt is not as simple as it looks. Because of this, G.U.I.D.E comes with a built-in formatter which handles all these things for us. Well, let's create a formatter then. We add a ready function, and in there we write var formatter. This is a G.U.I.D.E input formatter. And we initialize this with G.U.I.D.E input formatter for active contexts. Now we have a formatter, and we can now ask this formatter to give us a text with the input that is currently bound to an action. So we can say text equals formatter, action as text, action. Okay, let's run this. And our label shows WASD. Nice. Now let's switch to the controller and our label stays at WASD. Well, that's not good. Why is that? Well, we just got the text with the input from the formatter and we set this text to our label. But our formatter cannot know what we do with the text after we get it. So we will need to update our label text whenever the input mappings change. To help with this, G.U.I.D.E provides a signal to which we can listen. So let's first create a new function. We call this update label. And let's move this in here. Now the formatter will automatically keep track of the currently active mapping contexts. That is what this forActiveContext function actually does. So we don't need to create a new formatter every time, but instead we can move this line up here and let's maybe prefix the variable with an underscore so we know it's internal to our label. And then we can fix it down here in our update label function. Now we want to call our update label function whenever the mapping context changed. So let's add this to our ready function. G.U.I.D.E input mappings changed, connect, update label. And to be sure that our label is up to date when the game starts, let's also call update label right here. So let's give this a try. The label shows WASD. And if I start using the controller, it changes to left stick. Nice. But what if we wanted to get some nice icons for our input instead of some text? Well, G.U.I.D.E supports this as well. Instead of a label, we can use a rich text label. So let's change the line up here to extends rich text label. And then let's right-click our label here, change type, and we select rich text label. We need to do a bit of setup for this. So first up, let's enable BB code because we need BB code to render our icons. And then let's enable fit content. So our label will grow automatically when we add text. We also want to disable the scrolling because that will interfere with the label growing. And for the same reason, we will also disable auto wrap. And now we can see our dummy text again. We still need to fix the font size, so let's go down here to Theme Overrides and set the normal font size to 32 pixels. Okay, now how do we get icons instead of text? Well, we can just call a different function on our formatter here. To get icons, we call action as rich text async. Now, why is there an async in the name of the function here? Well, remember that I said that the labels on the keys depend on the locale that the player is using? If we had an icon for each key and each locale, we would need hundreds and hundreds of icons. Also, what if we don't like the built-in icons? We would need to make hundreds and hundreds of icons in our own custom style. And this is why G.U.I.D.E creates those icons on the fly when we request them. If we have a look into the internals of G.U.I.D.E, so we go to Add-ons, G.U.I.D.E, UI Renderers, we can see that there are a lot of renderers built in which render icons for various input devices. For example, there's a keyboard renderer here, and if we open the scene, we can see how icons for keys are created. We can also build and register our own custom renderers if we would like, but that is something for another video. Now, because G.U.I.D.E renders these icons on the fly, it may take a frame or two to actually create this icon. However, we don't want to block our game while this is done, so we just do an await on this method. So this async is just a reminder for us that we need to call await on the method. G.U.I.D.E will cache the icons, so if the icon that we want already exists, Guide will use the existing icon and this function will return immediately. So let's run the game and see how it works. And we see the WASD keys rendered up here. Now they're a bit too small for my liking, so how can we increase their size? Well, we can tell our desired size to our formatter when we create the formatter. So up here, where we create our formatter, we can give it an icon size as parameter. Well, let's set this to maybe 48 and see how that looks. And that's much better. Now, if I switch over to the controller, the label will render the stick icon. So we got the basics running, but just showing the input isn't really telling the player what to do. So we need to add some text. And we will also need to have different texts when we switch between build mode and walk mode. So let's make our label here into a little reusable component. First, we are going to need a text which we want to show to the player. We could use the labels text for that, but we're going to override that label text when we add formatted input. So I think it is better to have a separate export for this. So let's add one. Export multiline var prompt, and this is a string, and we initialize this with an empty string. And we're also going to need more than one action. So let's change this action export into an array. So now it becomes export var actions. This is an array of guide action. And we initialize this with an empty array. Now the compiler is unhappy about our line down here, so let's comment it out for the time being and replace it with a pause. So how will our component work? I would like to enter the prompt here. Something like use placeholder to move, placeholder to fire, and placeholder to switch to build mode. And then our label should replace these placeholders with formatted actions. We have 3 placeholders, so let's add 3 actions to our actions export. And then we drag in the move action, the shoot action, and the switch to build mode action. So now this is set up, so let's write the code to make it work. The first thing we need to do is to format each action into a rich text string. We need to store these rich text strings somewhere, so let's create an array for this. So var actions as rich text, this is an array of strings, and we initialize this with the empty array. And now let's resize this array so it has the same size as our actions array up here. So actions as rich text, resize, actions size. And now we can walk over our actions. So for I in action size, and then for each action we format the action as rich text. Now we only need to replace our placeholders from the input string with our formatted actions. And we can use Godot's built-in string formatting for that. So we can just write text equals prompt % actions as rich text. And this will replace all the %s in our prompt string with the formatted actions from our actions as rich text array. Okay, let's give this a try. And this works really well. Now let's also try switching to the controller. And our label updates and now shows the controller input. So let's see what happens if we switch to build mode. Well, our label updates, but because these actions are not available in build mode anymore, we have no icons in it. Also, the text that we have added is for walk mode and doesn't really fit for build mode. Another thing in build mode is that we have this hotbar down here, where the player can select a tower. And I think it would be nice to have an icon here as well. So we still need to do a bit of work for the build mode. Well, let's go back to the editor, and maybe we start with the label. I think we can just duplicate this label that we already have, and let's rename them. So this one we name input prompt walk mode. And this other one we name input prompt build mode. And now we can change the text for the build mode. Let's go with something like select a tower from the hotbar below, use placeholder to move the camera, placeholder to move the tower, placeholder to place a tower, and placeholder to cancel placement. Now, this is a pretty long text, so it will probably not fit on the screen. Well, let's try it out. And indeed, it doesn't fit on the screen. Now, given that we might localize this someday, we need our label to automatically grow to fit in the text. But we also want to keep it centered. Because this is a rich text label, we need to use the center tags to center the text. So let's add these. And now let's also enable word wrap, so the label automatically wraps words. And we can see that this is not going to work because our center container will compress the label down to a single pixel line. So we need to give our label a minimum size to counter that. Well, let's go with maybe 1200 pixels. That should do the trick. Okay, so now we need to drag in the actions. Let's do that. And then there's one more thing we need to do. We only want each of these labels to show when their correct mode is currently activated. So the build mode label should only show in build mode, and the walk mode label should only show in walk mode. Let's go into our code for the label, and then let's add a new export for show in context. This is an array of guide mapping context, and we initialize this with an empty array. So if there are some mapping contexts in this array, then we only want to show the label if at least one of these contexts in the array is currently active. And we can add this logic in our update label function. So first we check if the array is not empty. Now we want to check if there is any mapping context in our array that is currently enabled. And in fact, there is an any function built into Godot's arrays that we can use. So we write if show in contexts any, and now we need to give the any function another function. And the any function will call this function for each element in our array. So we write func context, and now our inner function will check if the current context is currently enabled. So return guide is mapping context enabled context. So now we know that there's at least one active mapping context. I don't want to nest all this code below in this if, so let's reverse the condition up here by adding a not. So now when we know that none of the mapping context is currently active, we can just make the label invisible and return. And otherwise, we make it visible, and the rest of the code can stay as it is. Great, so for this to work, we now need to drag in the correct mapping context. So for the walk mode label, we drag in our two walk mode mapping contexts. And for the build mode label, we drag in the build mode mapping contexts. Let's give this a try. So we are in walk mode, and we see the keyboard and mouse instructions for walk mode. Let's pick up a controller. The instructions change. Okay, let's go into build mode. We see the build mode instructions for the controller. Well, let's use the mouse, and the instructions are updated nicely. So that works really well. And the only thing that is missing is the icon for our hotbar. So let's do that. The user interface for the build mode is in the build mode scene. So let's open this up. And now we can see the tower label, which currently uses the hard-coded 1. So this label is already a rich text label, so we just need to enable BB code. And because this label really works exactly the same way as the other two input prompt labels that we have just created, we can simply attach the prompt label script to this label as well. Well, let's set the input prompt to a simple placeholder because we only want to show the icon. And then we can drag the select tower action into our actions array, and that should do the trick. Let's give this a try. We switch to build mode, and we got a nice icon down here. And if I change to the controller, Then the icon updates and now shows the controller binding. In this video, we had a look at how we can use G.U.I.D.E to implement support for controllers in our game, in addition to the keyboard and mouse support that we already had. We learned that we can bind input from multiple different devices to the same action, but that it is usually a better idea to separate mapping contexts for each device because it makes it easier to show correct input prompts and avoids having inputs from different devices fighting each other. We learned how to use modifiers like the scale, dead zone, and the virtual cursor modifier to make input from controllers look similar to input from the mouse for our game code. We learned that we can use the any input to switch between different input modes whenever we detect input from a certain type of device. And we learned how we can set up input handling so we can seamlessly switch between input devices without having to change any of our game code. Finally, we had a look at how to show input prompts to the player. We learned that we can use the G.U.I.D.E input formatter to show the input that is bound to an action. We learned that we can get the input both as text and as icons depending on what we need for our game. And we had a look at some techniques to keep the input prompts up to date whenever the input device or our game mode changes. There's still quite a bit more that we can do with G.U.I.D.E. It would be good if our game had a settings menu where the player could change the bound inputs while the game is running and configure things like input sensitivity and inversion for our camera controls. And it would also be nice if the game worked on mobile devices, so we would need to add support for touch input. We'll have a look at these topics in future videos. I hope this video has been helpful. If you have any questions or suggestions on how G.U.I.D.E could be improved, please post them in the comments. If you liked this video, please give it a thumbs up and consider subscribing to the channel to get notified when new videos are posted. Thank you very much and happy Godotneering!